Okay, we're going to go ahead and get started. There are people coming in, but I know people have time constraints and might have to leave by 8, so we got to get done. Thanks again for coming out. 7 o'clock on a Wednesday. Clubhouse One, Astronomy Club. Leave the rest of your life behind. And Chris, is that enough light? I think that's a little better. Okay, and we have several new people. I want to welcome anybody that's a first-timer or just checking out the club. And I'm Joe Cameron, the club president. I'll go through a few minutes of club activity, and then we'll turn it over to our guest speakers who have a really great presentation for us. Reviewing recent events, last month was Alan White with Ancient Coins. That was interesting if you were able to make it. And Val Akins, you're not here, are you, Val? But Val set up the telescope last month and got a really good shot. If he happens to come up tonight, Jupiter, Venus, and Mars are very prominent. If we don't have a telescope, you can just look up and enjoy them. But we're all on the same side of the sun right now, so it's kind of fun. Okay, and then right after our last meeting, this is kind of important. If you see on the left there, the star fight. This is a moon landing probe by a private sector company, Firefly. They call it the Blue Ghost. That's a firefly down in Southeast America, only exists there. But this is the first U.S. lander in over 50 years going to the moon now. So things are picking back up. That's kind of good news. It was launched on the 15th on a Falcon 9. You can see the fairing there that contained both space probes that are going to the moon and trying to land successfully. This is the Japanese unit that was on the bottom, and this was on the top. It has 10 NASA instruments. It'll have a 2-week mission life during daylight because it's solar powered. But you'll see on the next slide, we have a lunar eclipse coming up. So it'll be up on the moon, and the Earth will create an eclipse of the sun, which might give us some interesting information about looking at our own atmosphere in a blackout mode like that. And then the following day, we had the 7th Starship launched. It successfully, for the second time, came back to the launch pad. This is kind of a weak laser, but right here you get it. I don't know how many people saw that. It's worth going on YouTube and seeing this thing happen, come back and land right where it took off, which is a major change of space access. Unfortunately, the space module exploded, so hopefully there's some good lessons learned. Anybody know what the acronym is, RUDE? I think Elon Musk came up with that. It means Rapid Unscheduled Disassembly. This is just a little housekeeping note. The board got together and came up with a new tagline for this club itself: enriching lives in Laguna Woods by exploring our unique place in the universe. And the background is the Earthrise in 1968 on the Apollo program, looking at ourselves all on this little marble. So we're rewiring ourselves, and hopefully this club's contributing a little bit to that process. Okay, upcoming events this Saturday, we'll have stargazing, and Bob Odell will be hosting it. He's taken over for Alan White, and we're building a carpool. If you don't like to drive at night but want to go, we'll try and get you transportation to check it out. But it is a nice part-time a year when multiple planets are available if the weather permits. And then next month on the 12th, we'll be going to the California Science Center. I don't know, Stuart, do you have the number on the bus? How many signed up?
Right now we've got 43, room for 56, and that waiting list. We've always got people canceled, so yeah. And I'm gonna send out an email or open it up to the whole village. So if you're interested.
Yeah, we're about 80% full already on a 56-passenger bus, and after tonight, anybody in the village can sign up if they want to come. So if you want to do that, try and do it tonight or in the next couple of days. Should be a really fun outing. Although one unfortunate thing I just learned today is that this is a true statement. The shuttle is stacked and upright in its final display position. although it's not ready for public viewing. It's still wrapped in plastic, and they're doing other activities before it'll be available. So we may be able to get a look at it as far as a sense of size, but you can't see the details. But there's plenty of other things to see, early Gemini and Apollo modules, and it's a really fun day. Okay, and then astronomically, we do have the lunar eclipse on the 13th. We're lucky if you look down here, we're in the sweet spot. North America is right in the ideal spot. About 9 o'clock it'll start, midnight full, and then 3 a.m. clear. Of course, you know, some people are facing the sun and won't see any of it, so that'll be ideal if anybody likes to stay up.
Midnight.
This diagram just gives you an illustration of it's a lunar eclipse versus a solar eclipse.
Yeah,
Yes.
there is going to be a lunar eclipse party at Casper that night.
Oh, right. They'll be hosting that a late night event if you want to look at it at Casper's. It might be worth the drive, although if the skies are clear, I think you'd see it pretty much about the same quality from Laguna Woods right here. If anybody remembers the last one a few years ago. And then we're going to do our second annual outing to Joshua Tree. Stuart is the point of contact again, but it was a really nice weekend trip. Here's the dates. It's during our summer break, but from 18 to 20, we'll have a car caravan and some information about recommended lodging and timeline and where we'll gather. Last time about 30 people came with probably 10 or 12 different scopes. You can see the Milky Way out there. It's really a nice event if anybody's up for it. And then just a little plug, Stuart's already booked for this cruise. If you're interested in the Northern Lights, like Joe Brown captured for us last year in Norway, there will be an opportunity to do that if you want to fly to London, enjoy the city there, and then take a cruise north. So in summary, this is our orbit. Here's February. We're tracking around, the events going on. For new people, a couple highlights are, if you do decide to join and become a member, we put on 2 free parties, which most social events are more than $20 to go to already. So for $20, you get 2 free member appreciation parties, plus 9 lectures with interesting guest speakers, and then we coordinate field trips and other activities, again, to kind of leave all your personal affairs behind and think about the bigger picture. So with that, we have 2 speakers. They spoke twice last year for us. They have a wealth of knowledge. I won't steal any thunder, but can everybody please join me in welcoming Ruth and Richard, who will now speak to us.
Well, thank you all for being here tonight. And then they tell us we're going to be television stars as well, so that's pretty exciting. Thank you. Well, we're excited to be here and talk about the commercialization of space and the future of space exploration. But, as Albert Einstein once said, to understand the future, you need to look at the past. So I thought I'd kick this off with a very brief, Reader's Digest, very condensed version of the history of NASA. It actually dates back to 1915, when Woodrow Wilson formed the National Advisory Committee for Aeronautics. He felt at that time that the United States was falling behind Europe in the design and manufacture of aircraft. So he started this with $5,000 and 12 unpaid members. Over the next 40 years, the NACA did a tremendous amount of aeronautical research, which later transferred to the new nascent aerospace industry. In the 1950s, test pilots were flying experimental aircraft like the X-15 higher and faster than ever before. And at that time, the NACA thought, maybe we could put a human being into space. They actually designed a space capsule, much like we were using in the early days, with kind of a flat bottom and a heat shield to allow easy re-entry into Earth's atmosphere. And they designed a worldwide network to track all of our spacecraft, which is the Deep Space Network that we're using today. The space race actually started in the 1950s. 1955 was the International Geophysical Year. Groups of scientists from all over the world got together because they wanted to learn more about Earth. And they thought the best way to do that would be to put a scientific satellite into space so we could study Earth from above. The geophysical year was actually 18 months, from July 1st to December of 1958, 1957 to 1958. And the United States and the Soviet Union both pledged to put a scientific satellite into orbit around the Earth. But as you might expect, the two countries took a very different approach. The Soviet Union worked in total secrecy, and we didn't know what they were doing until they announced the launch of Sputnik on October 4th of 1957. Now, Sputnik did not contain any scientific instrumentation, but this 184-pound ball had a major impact on the United States and our race for space. And of course, in 1961, the Soviets put Yuri Gagarin in as the first man to orbit the Earth. The Eisenhower administration backed the Vanguard project. And this little tiny space capsule here did contain scientific instrumentation. But unlike the Soviets, we didn't do this in total secrecy. We did this in front of the world press. The Vanguard launched, it got 4 feet above the surface. The main engine lost thrust, and it came crashing back to Earth in a huge fireball. The little satellite, however, was thrown clear, a little bit beat up for the damage, but it was retrieved by our scientists. So this public humiliation forced President Eisenhower to approach the Army, the Navy, and the Air Force and say, you will have a scientific satellite in orbit around Earth within 90 days. No pressure. Well, we met that goal. The Explorer 1 was a project of the U.S. Army, and it was built by Caltech's Jet Propulsion Laboratory. It was tiny. You can see that it could be held aloft victoriously by 3 people, and it was a victory, because our first foray into space, we discovered something we had no idea even existed. We discovered the Van Allen radiation belts. These belts surround the Earth. They're like big donuts with the Earth in the center. They're made up of ions and very fast-moving particles that travel about the speed of light at 186,000 miles per second. Now, they can be harmful to our spacecraft, but they do protect the Earth from the solar wind, the very high energy particles that are being emitted from the sun continuously. And that little Explorer 1 spacecraft, we lost contact with it in May of 1958, but it kept orbiting the Earth for about another 58,000 orbits. And it came back, burned up in Earth's atmosphere in 1970. So another 100 spacecraft after that carried the Explorer designation. Now, in 1957, Congress was talking about forming an agency to manage our civilian space program. President, or soon-to-be President Johnson, he was chairman of the Special Committee on Space and Astronautics, said, "There are no blueprints or roadmaps which clearly mark out the course. The limits of the job are no less than the limits of the universe." In 1958, President Eisenhower asked Congress to pass legislation to form this special agency to handle our civil and commercial space program. He appointed Dr. Keith Glennon as its director and Dr. Hugh Dryden as the deputy director. And on October 1st of 1958, all of the assets from the old NACA and the personnel were transferred to this new agency called NASA. The first project was Project Gemini. The goal was to put a man into space orbiting the Earth to study how he could function in this type of an environment and to bring him back to Earth safely.
Mercury.
Project Mercury. Oh, I'm sorry, Project Mercury. Gemini comes next. These are the Mercury 7. These are the brave men that said, oh, pick me, I want to go, I want to go. Alan Shepard was the first American to fly into space, and John Glenn was the first American to orbit the Earth in 1961 and 1962, respectively. Now we come to Project Gemini, and this was really our bridge to the moon. The first mission in 1965 orbited the Earth 3 times. And during this time, NASA was busy developing the technology to make a safe lunar landing. That was the goal and the dream. At this time also, NASA invented the fuel cell, which is a chemical reaction of liquid hydrogen and liquid oxygen to generate electricity. These fuel cells generated enough power and water so that the astronauts could break that 3-day orbit record. They also honed the technology to bring us back through the atmosphere and land safely on Earth. And it was the time of our first spacewalk. Ed White was the first man to walk in space. He was outside of the space capsule for 23 minutes, and he logged 6,500 frequent flyer miles in orbit. Anybody old enough out here to remember this moment? Just a few of you? Yeah. I was glued to a black and white television set, and I think I held my breath for hours waiting for Neil Armstrong to finally set foot on the moon and make that famous statement. This was a dream, a goal of President John F. Kennedy, established in 1961, and he wanted it completed within the decade. But it was more than just landing a man on the moon. This was about the United States gaining preeminence in space. It was about developing technology for future scientific missions. And it was about learning how to live and work in the lunar environment. Now, during Project Apollo, we drove for the first time on the moon. And I have to tell you, I remember this day very well because it was my wedding day. Oh, it gets better. My father worked for RCA in Camden, New Jersey. And the division he worked with worked on the communication modules for the Mercury, the Gemini, and the Apollo missions. And he absolutely refused to walk me down the aisle until he knew we had communication and everything was safe. So I was late for my wedding, and it didn't bode well for the future, but that's another story. This led to Skylab. Now we wanted to live in space. Three-man crews. spent 171 days and 13 hours living on Skylab. This was really the highlight of the 1970s. But it was fraught with a few problems. This is the first crew. And they had a rather important mission. It was called Save Skylab. Skylab was in trouble immediately after launch. The micrometeorite shield deployed 63 seconds after launch. And the aerodynamic forces just ripped it off the spacecraft. Additionally, with that, it took the solar shields. And the solar panels never deployed. So these guys said, hey, we can fix anything. That was their motto. The launch was actually delayed about 10 days while the engineers worked with seamstresses to sew a huge parasol, which when they got there, they deployed it through an airlock. It covered up the spacecraft, provided the heat shield that was necessary, and they got the solar panels to deploy. So instead of being overheated and without power, they had cooling and they had power to operate the craft. You guys are going to be lucky to maybe get a little glimpse of the shuttle. This was our first reusable spacecraft. It launched like a rocket. It orbited Earth like a spacecraft, and it landed like an airplane. Now, as the astronauts went back and forth from Skylab, they went on to the Apollo spacecraft. But we had to figure out a better way to do this if we were actually going to spend any time living in space. So the space shuttle was developed and flew from 1981 to 2011. During that time, it boosted more than 3 million pounds of cargo into space, mostly to build the space station. And it was the only craft that was large enough to put satellites into and out of space. So now that we had this, we had to test it, which led to the Shuttle Mir program. 7 American astronauts spent almost 1,000 days with 7 cosmonauts from Russia living aboard the Mir. And the space shuttle rendezvoused 10 times with this space station. This, of course, led to the ISS. The International Space Station is celebrating its 25th anniversary this year, which is, pretty amazing. The first crew went up in November 2nd of 2000, and it has been continuously manned and staffed. It is a research laboratory that orbits in low Earth orbit at 250 miles above the surface of the Earth. It travels at a speed of 17,500 miles per hour and makes 16 orbits of the Earth every day. Now, I don't know about you, but that made me really dizzy when I thought about that. But that's what keeps it in orbit. The life of the space station has been expended a number of times. And because the parts are modular, they can be replaced or repaired and maybe even improved along the way. So it's constantly monitored to be sure that our astronauts are safe, and it will continue to operate now as an outpost and research laboratory at least through 2030. This is our current crew, Expedition 72, over that 25-year period. They launched last September, and their mission will end sometime this spring. They're doing some really incredible research that affects us here on Earth, as well as off Earth. So they are looking at pharmaceutical manufacturing. They are looking at genetic sequencing and microgravity. And they're looking at advanced life support systems, among other things. So what's next? The Artemis mission. This is our human return to the moon. As Joe said, the Firefly, we haven't had anything there for 50 years. Artemis 1 launched in November of 2022. It was uncrewed and it orbited the Earth. It was to test the Space Launch Program and the new Orion space capsule. This is our crew for the Artemis 2 mission, which is now slated to launch in April of 2026. They will again orbit. It's a 10-day project and return to Earth, all in preparation for Artemis 3. This is when we will actually land again on the moon and do scientific research at the lunar South Pole. But NASA has more than crewed missions, and I've just given you the highlights of those. This is our science suite. We orbit the Earth, the Moon, Mars, the Sun. The Europa Clipper just launched to go to Jupiter. We've got the James Webb Space Telescope sending back some amazing images of our universe. So this very busy slide just tells you the reach that NASA has in the universe. And with that, I'm going to turn it over to Richard to talk about the future of space exploration and our commercialization.
Thank you, Ruth. I learned a lot. I'm going to take you through what the future holds. Now, I don't have a really clear crystal ball, but there's some facts and there's some plans and there's some schedules that I'm going to share with you. And hopefully we'll be able to make sense of what's happening today and the next decade or so. But just to review for a second, everything that Ruth described was all government funded. It was paid for with your tax dollars via NASA contracts. For the most part, those contracts went to large manufacturers like Rockwell and Boeing and other major corporations here in the United States to build the vehicles, the rockets, the engines, the landing craft, all of that. So in a real sense, space has already been commercialized right up through the current day. Science through the 50s, through the 90s, was all funded with government money. And then commercial companies started taking over small pieces of it. And this timeline gives you an idea of where we come from. It also gives you an idea of where we're going. Now, some of you may recognize this fellow. He currently resides in the White House, I believe. But he also owns a company called SpaceX. And he certainly has made a name for himself, designing and launching some incredible vehicles. But he didn't do it all with his own money. In fact, he received about over $14 billion from NASA since 2008 to fund the development of the rockets, which have been so successful, the Falcon 9 rockets that are launching on a routine basis now. This company has grown immensely. He's got a lot of investors, of course. A lot of money has been made by SpaceX. But literally, that wouldn't have been possible without the seed money that came from NASA and a few investors. So some of you may also recognize this guy. He delivers packages to your door. He owns a company called Amazon. He also owns a company called Blue Origin. And these two gentlemen seem to be the face of commercialization these days, but there's a lot more going on with space exploration and space exploitation, as we will see. NASA currently relies on a fleet of 7 commercial launch vehicles, and here they are. From the small Pegasus XL, which launches from an airplane, on up to the United Launch Alliance Vulcan rocket, and the brand new Blue Origin rocket called New Glenn, which, by the way, is named after John Glenn, the first American who orbited space. SpaceX has 2 rockets in there, the Falcon 9 and the Falcon Heavy. These rockets are all used to launch satellites, space probes, and various equipment into space for NASA. NASA contracts with these companies to do this. They maintain, they launch, they retrieve, they rebuild. There's a whole program at NASA called the Launch Services Program, which manages that. Which rocket is used? Well, that depends on the payloads, how much mass, where it needs to go. If it's going to Jupiter, kind of a booster rocket that needs to be launched along with it. There's a lot of decisions that go into this. But there's actually much more out there. Currently, there's 9 launch vehicles that I'm aware of that are launching payloads into low Earth orbit, or LEO as we abbreviate it, or higher. Low Earth orbit is where the space station and the space shuttle resided. There's other distances from the Earth that you can launch satellites to and space probes to, of course. Geosynchronous orbits are in a much higher orbit, for example. Those are the ones which we rely on for communications and GPS. But under development, as we speak, are another 39 launch vehicles. Commercial companies are developing these launch vehicles for various purposes. The question is, why? Some of these companies you've never heard of, probably. ULA stands for United Launch Alliance. Relativity, Rocket Lab. When you go up to the California Science Center, you'll see a Rocket Lab electron rocket on display there. Boeing, well, they're very well known. Firefly was mentioned a bit earlier. Orbital, there's a Chinese commercial company. There's Russian commercial companies. There's European commercial companies, all vying for this piece of commercial space. So again, we can ask the question, why? Why all the interest? Simple, money. Or better put, risk versus reward. There's a lot of money to be made by launching stuff into space. The question is, how risky is it? How likely are you going to be successful versus how many failures you're going to have? How much money do you need to spend and lose before you start making money? Well, the US government has put their finger on that scale to a large extent over the past several decades. And this is why those companies are so interested in space. Now, this goes back to Ronald Reagan. In 1983, he pushed for increased commercial launches and development of the space market. He had this vision that the commercial companies were going to take over a large part of what NASA does, which was pretty exciting. I remember, well, let me ask this. How many of you have seen the movie 2001? Space Odyssey. Pretty classic movie. You remember the vehicle that the astronauts launched upon? It had a Pan Am logo on the side. Now, Pan Am doesn't exist anymore, but the idea certainly stuck. Then in 1984, Congress passed the Commercial Space Launch Act, which legalized commercial launches. Up to that point, only the government would give itself permission to actually launch a rocket. So all of a sudden, all the agencies, all the alphabet agencies of the government could now start contracting with private companies to start launching their satellites, their spy satellites, their communication satellites, etc. And then 2006, NASA starts getting really serious. They rolled out what was referred to as the COTS program, that I'll describe in just a moment. And President Obama in 2010 further accelerated this program. About this time, the space shuttle program was coming to an end. And we realized we had no way of getting astronauts up to the space station without the space shuttle. So they started paying the Russian government about $80 million per seat to deliver our astronauts to the International Space Station. Well, that didn't go over really well with Congress. So the idea was hatched to encourage commercial companies to fill that role. And what was launched was the Commercial Orbital Transportation Services Program, managed by NASA. It started with $800 million contract, and it resulted in 2 medium-class launch vehicles and 2 cargo spacecraft built by SpaceX and Orbital Sciences. That's where Elon Musk's money started flowing in. And that's where Orbital Sciences started developing their vehicle. Following that was the Commercial Resupply Services Program, again managed by NASA. Now we're talking about real money. You think back to the origins of NASA, the agency that was created under the Eisenhower administration with $5,000. We're talking $16 billion with a B dollars for the Commercial Resupply Services. This was to deliver food and water and scientific experiments to the International Space Station. Multi-billion-dollar contracts were awarded to several companies in 2008 through 2016. And then the big dollars started flowing for crew delivery, delivering astronauts to the International Space Station. In 2010, $50 million went to Blue Origin, Boeing, Paragon, Sierra Nevada, a total of $8.6 billion to get our astronauts to the International Space Station. Russia lost a significant amount of revenue all of a sudden. And this program has been very, very successful. This is that proverbial finger on the scale that I was talking about. The US government was spending a lot of money to make this happen. And it doesn't stop there. As Ruth mentioned, we're going back to the moon with the Artemis program. And to get there, NASA has designed and built, through its commercial partners, a new launch vehicle called the Space Launch System, or SLS. And there's several versions of the SLS. We've launched the first block, as it's called, Block 1 version, and it orbited the moon already with its capsule, the Orion capsule, and returned safely. It was uncrewed, and as Ruth mentioned, the next launch will actually be crewed and will again circle the moon. In a very similar fashion to how the Apollo program was run. Little steps at a time. They're not actually little steps, they're pretty big, expensive steps. But we want to make sure it's done right, it's done safely. But there are many other components to the Artemis program that the commercial companies are participating in. Joe mentioned the recent launch of SpaceX's Starship. And they've been building this rocket, which will eventually be the most powerful rocket certified to bring, cargo into space and one day astronauts into space. Up until that time, the SLS holds the title as the most powerful rocket, more powerful than the Saturn V. And we're talking about power, we're talking about the ability of carrying heavy stuff into space. But SpaceX has been given a contract to take that top portion of the Starship. I'm referring to this part up here, which they call ship, just ship, half of Starship. They're going to build a version of that for landing astronauts on the moon. Not from Earth, not taking them all the way from Earth to the moon, but taking them from a space station in orbit around the moon down to the lunar surface and then back up to the lunar surface. So since it's not going through the Earth's atmosphere, well, it's only going through the Earth's atmosphere once, it's not returning through the Earth's atmosphere. They can get rid of a lot of the heat shield and a lot of equipment that's not needed. By the way, these two rockets being compared here on this slide to the Saturn V, you can visit Saturn V rockets laying horizontally on the ground in Houston and in Florida at the Space Center there. I've done that at both locations. Walking from one end to the other end literally takes about 4.5 minutes. I timed it. And I don't walk that slow. I'm getting slower, but I don't walk that slow. Now, there's other commercial development being developed for Artemis. NASA loves acronyms. So there it is, CLPS, CLIPS, Commercial Lunar Payload Services, delivering food, water, scientific equipment, supplies, tools, anything you can think of to the lunar surface. And there's $2.7 billion with a B scheduled to be spent with several companies listed below there to deliver this payload. And this is happening as we speak. As Joe mentioned, the Firefly Blue Ghost, it's on its way to the moon. It's in orbit around the moon. The intuitive machines, IM-1, IM-2 machines will be launched later this year. Blue Origin has also a contract to build a lunar lander, much like the SpaceX ship. So there's a lot of money being spent, a lot of development being done in preparation of landing astronauts on the moon. And then there's the Human Landing System Program, or HLS. $6.3 billion in contracts to deliver astronauts and cargo to the lunar surface. This is all going to either SpaceX or Blue Origin this time. A lot of money. And here are artists' renditions of what these spacecraft will look like. Now, they're not to the same scale. Notice on the picture on the right is the Blue Origin, and there's an astronaut standing there. So this is a pretty tall rocket. Well, if we look to the left, this is SpaceX's spacecraft, and there are two astronauts standing right there. It's even bigger. I swear I've seen this particular spacecraft in a science fiction movie at some time in my life. I'm positive I've seen it. I think that's where Elon got the idea. But there's scientific equipment being delivered to the moon as we speak. Here's a picture of the Firefly Blue Ghost, which is in orbit around the moon right now. And here's a picture of the iSpace Resilience spacecraft, which also launched at the same time aboard that Falcon 9. iSpace is a Japanese-based company. Again, contracted with NASA to build this spacecraft, this lander, to deliver equipment to the moon. The iSpace Resilience craft will fly past the moon and months later return to the moon. So it's a different type of route than the Firefly is taking. It's going to take about 4 or 5 months to land. From now, it's not going to land for another 4 or 5 months, whereas the Firefly is scheduled to land in March. So we should get some exciting pictures and information back from Firefly when that actually lands. Of course, there's a magazine about all this that you can subscribe to. I believe it's monthly, the Space Report. And once a year, they report on the status of space, as if it's going anywhere. They haven't come out with a report yet that I know of for 2024, but they report that 2023 was the busiest year yet for commercial space activities. $570 billion worth of revenue was generated by the commercial companies. That's over 7% growth over the previous year. Globally, not just the United States, but globally, there were 223 launches. 212 were successful. That's a pretty good success rate, which itself is a 33% increase over the previous year. 2,800 satellites were deployed. Now, I think you folks recently had a talk about the Starlink satellites. Did you know?
Not specifically. You might be going to a little bit.
Sure. So this is small satellites, constellations of satellites that are being launched by SpaceX to provide worldwide internet access. If any of you have motorhome, for example, and go camping, you may see other campers with a flat satellite receiver sitting on a tripod. That little square, which is no more than a foot square, is receiving television, streaming television signals from Starlink satellites. The plan is to deploy about 30,000 of these satellites into low Earth orbit. Why such a large number? Because every day, a dozen or so of those satellites deorbit and burn up as they come back down. So this has been going on for several years now. SpaceX launching these aboard Falcon 9 rockets. They're very often launched out of Vandenberg, in California here, just north of Santa Barbara. There are websites that'll tell you when these launches take place. And if they're nighttime launch, they produce fantastic light shows that I've seen myself and many of you maybe have as well. You can even see the satellites. If one night you're outside after dark and you see a string of lights kind of following, like a train of lights moving through the sky, I can almost guarantee they're not aliens. They are probably Starlink satellites that were just released from a Falcon 9. Well, of those 2,800 satellites deployed in 2023, 90% of them were commercial, so only 10% were government, like spy satellites, communication satellites, weather satellites. 79% of them were SpaceX's. So they're launching a lot of stuff into lower orbit, which has ruffled some feathers. In fact, astronomers are not happy because a lot of their images are coming back with streaks from all these satellites. 30,000 satellites are going to be up there photobombing astronomers' images. There's a lot more going on than just the moon, though, and satellites in low Earth orbit. A lot of these satellites are for communications and the internet, as I just described. But there's activities being performed right now to prepare for space tourism. How many people want to pluck down $250,000 to go into orbit? Well, I'd like to. I don't have the money, but I'd like to. That's happening and has already happened. There are plans for mining the moon. There are plans for manufacturing. Ruth talked about the experiments that are being done on the International Space Station. There are plans for generating energy up in space and making efforts to protect the climate here in the United States or in the world, and also supporting agriculture. This is what a commercial economy looks like, and a commercial space economy looks like, as far as we know today. The future could be, much broader. The Sierra Space folks have designed what they call the Dream Chaser, which is a small version of the space shuttle. Will carry 6 to 8 astronauts up to the International Space Station. It's also going to support space tourism, deliver people like you and I to a space station that's being planned by our friend Jeff Bezos at Blue Origin, called the Orbital Reef. This will be a floating hotel. You could fly the Dream Chaser up to the orbital reef and spend a week or two if you'd like. Commercial companies will pay to send their chemists and biologists and engineers to the orbital reef. They're hoping to do further experiments and produce very unique pharmaceuticals and other materials. NASA provided $130 million to Blue Origin to come up with this concept. That's where the seed money came from for Orbital Reef. I had the pleasure of escorting the folks, some engineers from Sierra Nevada, to the space to the Endeavor exhibit up at the California Science Center. This was before the pandemic. And the reason I remember that, not so much that they were a lot of fun, generally engineers are not, but I got to spend 3 hours inside the space shuttle with them as they looked at every system they could get their hands on to learn from NASA how they designed the space shuttle so they could build the Dream Chaser. It was the most exciting 3 hours of my life. Okay, the future. What I just described is the near future. Let's talk about a little further out. We're going to the moon primarily to learn about cislunar space and living on another body, another planet, in preparation of potentially going to Mars one day. And the Artemis program has that built in, just to eventually send astronauts to Mars. But there's a lot of other reasons to go to the moon. There's a lot of potential for commercial benefit from the moon. There is frozen water on the moon, and that water can be collected and broken down for rocket fuel to generate electricity through fuel cells that Ruth was describing, and just maybe growing crops and hydrating our astronauts there. The devices you see to the right are autonomous robots. I led a team of engineers a couple of years back in a challenge that NASA hosted to come up with autonomous robots that could mine the frozen water in the regolith on the moon. And these are actual drawings that we submitted with our concept. I didn't get any of those millions of dollars. But it was a fun thing to do. Also on the moon, potentially, there's aluminum to be mined, iron, magnesium, titanium, helium-3, which can be used to fuel fusion reactors. And then something that's been in the news recently, and has been a concern for a while, rare earth elements, which, contrary to their name, are not rare at all, but they are a little difficult to get to here on Earth. And it turns out that China has the biggest store, or the biggest supplies of rare earth elements, and they're not exporting them to the United States anymore. Why is that important? Because rare earth elements are important for all the electronics that you use, and lithium batteries, and everything that you can think of that we rely on in terms of electronics today. Chances are there's a rare earth element that's used in the manufacture of that. All of this can be found we believe, on the moon. So there's real potential for mining the moon and bringing these raw materials back to Earth. But it doesn't end there. Now, you probably have no idea what you're looking at right now. And I'm not sure I do either. But somebody took the time and identified a whole bunch of the known asteroids in our solar system. And based upon their mass and what we know scientifically about them, estimated what kind of metals are there. And if we zoom in here a little bit, you can get a sense of what we're talking about in terms of potential revenue. If you could send an automated mining robot to this asteroid called L.W.V, it contains about $5.73 quintillion worth of minerals and metals. What's a quintillion? That's a billion. Even these small asteroids, for example, could contain more titanium than has been mined here on Earth in the entire history of mankind. Asteroids are the building blocks of the solar system. This is Costco on steroids to an unimaginable level. This asteroid here, $7.7 quadrillion worth of nickel, iron, hydrogen. It's inconceivable, the potential, commercial potential that these rocks floating around our solar system have. This is the golden prize for the commercial companies. Because it's difficult to mine here on Earth. It's expensive. Also, with all the environmental regulations and constraints for protecting our environment, there are limitations to what we can do. But no one's going to really care if you tear apart an asteroid. There's nobody living there. There's no plants, there's no animals. It's just a big rock, just waiting to be picked up and delivered to us for some future manufacturing purpose. And this is, as I said, the golden prize for the commercial companies. It all boils down to dollars. Big dollars. So if you thought billion was big, we got bigger numbers to talk about. So that's where the commercialization of space is coming from and where it's going, potentially where it could go. And now we'd be happy to take your questions. Okay. Yeah, this gentleman here.
If I'm reading your charts right, in the last year you gave quotes for, the governments of the world spend close to $500 billion on space. All that money is going out. It is all being invested. And it's going to private, hello?
And it's going to private companies, so they can go back and drag out an asteroid or whatever they're going to do with it. And they're going to make the money out of it. How does the taxpayer benefit from that? Would that $1 trillion be better spent doing something here on Earth? I mean, you have to ask if this is worth doing. I mean, if you go out, let's say you find an asteroid that's made out of gold, solid gold, and you bring it back, you know, and it's for 1 trillion tons. Well, gold's not worth anything anymore. It's cheap, okay? So you didn't make anything. And if you did make it, how does it get back to the taxpayer? I question the economics of what's going on here. You're making a lot of companies rich, but they're using our tax dollars to do it.
That's a very fair question. Probably one way above my pay grade. But I'll give it a try. We rely on raw materials, you know, for our life, for our lifestyles. Okay. We rely on raw materials for the medicines that, you know, keep us alive. We rely on the raw materials that go into the cell phones which entertain us. And who knows what's coming in the future in terms of technology. So they have always been developed by commercial entities, produced by commercial entities. The U.S. government has always seen its role through entities like the National Institutes of Health and the National Science Foundation to spur research, to fund research, and then spur development by commercial companies to bring us these marvels that save our lives, that enrich our lives, etc. Obviously, there's a balance. Obviously, you know, your example of bringing back solid gold is going to crash the value of gold. So I would imagine somebody or a company wouldn't do that. I'll give you another example of that. On Neptune, we think it rains diamonds. How many of us would love to go there with a hat, just hold it out, and bring it back? But obviously, that's not going to help the situation. It's a very fair question to ask. NASA's role is to spur discovery. The economy, the commercial economy's role is to enrich all of us in some way. Whether it does that well or not, you know, that's beyond my pay grade. Ruth, did you want to tackle that one?
No, I think you did a good job on that, but you do have to think about some of the things that we use every day that we wouldn't have if we didn't have space exploration. So a lot of the things that we use now are because we've done all of our research in space. The tires that you drive on, your cell phone, the ability to flip your phone one way or the other, that all came from space exploration, not only Tang.
MRIs, CAT scans, Velcro. I love Velcro.
Another question?
Okay, your last chart, which had all those asteroids and the potential economic implications of the various asteroids, is there a system in place that's going to control how the mining of all that will take place? Or is it just going to be a land rush, so to speak? Anybody who gets there first claims it, or is there some kind of system?
There is a very skimpy international legal protocol in place that deals with the moon currently. In fact, NASA, as part of the Artemis program, has fostered what they call the Artemis protocols. And several countries have signed on to those protocols, which basically say no country is going to claim the moon in its entirety for itself, that it's, you know, it's for humanity, humanity's benefit. But beyond that, there really isn't any legal structure that's going to govern this at this point in time. The lady here.
Here, we have the mic.
Oh, okay.
Go to Anna.
Okay, I did a little bit of looking things up. In 24, 87% of the rockets launched in the United States came from SpaceX. SpaceX has 82% of all the American satellites. Musk's wealth went up $170 billion just since the election. And they fired the 5 inspector generals checking out Tesla and SpaceX and his Neuralink hobby. But does NASA have any obligation to spread the wealth around, or is all this just, are you allowed to even address that?
Well, first off, let me preface by saying neither Ruth or I are spokespeople for NASA. So we can't speak for NASA. We are trained volunteers that talk about NASA missions. Any opinions that we express are our own. From what I know about NASA is that everything that it does is governed by law. Specifically, you know, laws that are passed by Congress. So when you talk about spreading the wealth and such, that has to be in the law in order for NASA to do it. So there's specific protocols in place to award contracts based upon technical feasibility and capabilities and things like that. But there's, you know, may not be something specifically in place to address your concern about making sure that Elon Musk doesn't make another $1 billion off the contract. So, do you want to add anything to that? Okay. Hopefully that answers your question.
I think it's a simple question. So you mentioned that whether it's Elon or Blue, you know, that's what's going to.
Jeff Bezos, yes.
So they receive government taxpayers' money for seed money, and then they start making all this money. Are they still continuing to receive money from the government?
Yes, there are ongoing contracts for developing new technologies and such. Yes.
This wasn't my real question, but whatever money that Elon Musk made, there's 2 aspects to it. One is that he was capable of doing those missions, and apparently other people weren't. The second is since the current administration has only existed for barely 1 month, all those hundreds of billions of dollars that Elon Musk made, he made under the aegis of the Biden administration. But my real question I was going to ask was, what are the practicalities of moving all of those minerals in a rocket from where the astronauts back to Earth? I mean, how much of that stuff can a rocket carry?
Excellent question. So the bigger the rocket, generally, the more that it can carry. And I'm sure that's what SpaceX is thinking about when it designed the Starship. It's going to be the largest rocket by far that's ever been built. You know, some tens of times more powerful than the Saturn V. I don't remember the exact multiplier. So it's not likely that they'll move a whole asteroid, although NASA has experimented with making minor changes to an asteroid trajectory. That's solely with the intent to save us if ever an asteroid would, had us in its sights. But more than likely, a space economy based upon mining would also incorporate manufacturing in space. So maybe there'll be manufacturing facilities close to that asteroid.
Question over here.
Yes.
Thank you so much. This is a fabulous presentation. I'm fascinated. I have a very mundane question to ask. I have a car that has OnStar associated with it. Is that, what technology is that? Is that Starlink, or is that, because I know it's unique, and I just wondered if you know what propels that.
Okay, so OnStar is a cellular-based system, which in the days that it was introduced, it was very advanced. Nowadays, you can find similar technology built into things they call the Internet of Things, IoT, thermometers, thermostats, not just vehicles and such. So it's a very handy communication tool, which wouldn't be possible without cellular technology.
I want to add something. My car was stolen. We were in Palm Springs, and because we had OnStar on the car, they were able to find the car.
Yeah.
So I'd like to get that.
I just have one correction. Velcro was invented by George de Maestro in 1947, so I don't think it had anything to do with the space age.
Well, thank you. Thank you for that correction.
Anyone else got something, really interesting information here? One in the front, and then maybe we'll wrap it up.
Well, I'm kind of humans have been around for 50,000 years. You never put a time scale on any of these things you were talking about, but even if you're talking about 1,000 years from now, getting to these outer space objects is going to be very difficult, even with nuclear power, and I don't know what else may come along. But I think we should be focusing on what do we have here on Earth, and how are we going to live 1,000 years with what we have here on Earth, and how do we cut back, because we aren't going to be able to consume the way we've been consuming.
Excellent points. I think those are all excellent points. Just one thing to correct. We've actually visited several asteroids, and it's not that hard to get to many asteroids. We've landed spacecraft on asteroids, touched asteroids. We've returned samples from asteroids. So they're not that hard to get to. They're in our solar system, and we've traveled outside of our solar system. But, I mean, your point is well taken about, using resources wisely.
What came back? I mean, how did it change life on Earth? It did significantly.
Well, you'd be surprised to what the space program how it has affected our lives, today. I mean, the way I like to put it is that discovery spurs invention. And that's been the story of NASA from the beginning. Every year, NASA publishes a booklet, and they list approximately 1,000 inventions or devices or medicines or things that people use daily that came from the space program. So you'd be amazed at what, you rely on today, we all rely on today, that actually possibly wouldn't have existed without NASA. So it's an interesting way of thinking about it.
Applications should.
Thank you very much for the questions. We'll be here for a few minutes.